All right, thank you so much for joining us today. So in this video, we are going to talk about the method 3, where the discriminant is less than 0, right? So we saw that when the root is distinct and it is complex numbers, then our general solution should be this, right? So let's take some example. And then the tip that I want to give you here is anytime the question is open and you want to solve like this, when you are finding the characteristics root, it's always advisable to use the quadratic formula, because sometimes when the function is complex, you won't see that it's going to give you complex root and you'll be struggling looking for the root. So it's good for you to use the quadratic formulas to solve. So let's go through the same process again. Here we are going to let y to be equal to e to the power mx, as we know, and then this is going to give us y prime is equal to me to the power mx, and then y prime prime is going to give us m squared e to the power mx. Now let's go and do substitution. So we are going to have y prime prime, which is equal to, so m squared e to the power mx minus plus me to the power mx plus 10 e to the power mx is equal to 0. So same process again, factor e to the power mx out, m squared plus 2m plus 10 is equal to 0. So you see that we are repeating the same process again. And then now we are going to talk about e to the power m is not equal to 0. Then my p of m is m squared plus 2m plus 10. So here, I know that I'm working through complex. So definitely my root is going to be a complex one. And the only way that I can see is to use the quadratic formula. So that's why I'm saying that it's good for you to use the quadratic formula always. Now let's look at what we can get from here. A is 1, B is 2, and C is 10. So what are we going to get? Our M is going to be minus B plus or minus B squared minus 4AC divided by 2A. So this is going to give us m. B is minus 2 plus or minus 2 squared minus 4 times 1 times 10 divided by 2 times 1. So this is going to give us minus 2 plus or minus square root of 4 minus 40 divided by 2. So what can we see? We can see that 4 minus 40 is equal to minus 36, which is less than 0. So this is going to give us complex root. So this is going to give us minus 2 plus or minus square root of minus 36 divided by 2. Now we know that root of 36 is 6, and then we also know that root of minus 1 is I. So this is going to help us to have something like minus 2 plus or minus 6i divided by 2. So now let me split them into m1, m2. So okay, let me write this one as minus 2 divided by 2 plus or minus 6 divided by 2i, and this is going to give us minus 1 plus or minus 3i. Good. So my m1 will be minus 1 plus 3i, and then my m2 will be equal to minus 1 minus 3i. Right. So this is what I'm going to get for m1 and m2. Now, what is the general solution for this? The general solution is e to the power ux k1 cos vin x plus sine vin x. Okay, I need to bring k2 sine vin x that. Now remember our m, so here we don't choose this from m1, m2. We choose it from the whole of this. So here our m is equal to minus plus or minus 3i, which is in the form of u plus or minus vin I. So here our u is equal to minus 1 and our vin is equal to 3. Good. So we are going to have something like this. Y is equal to e to the power minus x, k1 cos 3x plus k2 sine 3x. So this is what we are going to get at the end of the question. There is no initial value or initial condition, so this is just going to give us the general solution and we are done. So general solution. Good. So this is the process of working when the discriminant aspect is less than 0. So the same process but different general solution. So here what is important is after you have mastered the procedure, what you need to also master is remember the general solution for each particular case or method, right? Let's take another one, but this one with initial condition. So you go through the same process. I'll pick my y to be equal to e to the power this, and my y prime to be equal to m e to the power mx, and then my y prime prime to be equal to m squared e to the power mx. Good. So I'm going to have m squared. Now don't forget d squared y over dx squared is the same as y prime prime. So if I have the squared y divided by the x squared, this is the same as y prime prime. So if we see something like that, e to the power mx minus 2 dy over dx is the same as y prime. So I'm going to have mux plus 5 times this is equal to 0. So let's go through the same procedure again. Factor e to the power mx out. M squared minus 2m plus 5 is equal to 0. And then what can we do again? We can say that this guy is never 0. So it means that the characteristics polynomial is the one that should be equal to 0. So I'll pick m squared minus 2m plus 5 to be equal to 0. Then what I just need to do is I'll pick my a is 1, b is minus 2, and c is equal to 5. Now, one way of detecting that this is going to be complex is, you see that this 5 here, even when you square the b, it's less than this. So it means that this is going to give us complex. So now our m will be equal to minus 2 plus or minus square root of minus 2 squared minus 4 times 1 times 5 divided by 2 times 1. So I hope you have understood what I'm doing here, because I skipped writing the quadratic formula. So this is 20 divided by 2, and then we see that 4 minus 20 is equal to minus 16. So this is going to give us 2 plus or minus square root of minus 16 divided by 2. So as I said, minus 16, root of 16 is 4, but minus 1 is I. So this is going to give us 4i divided by 2, and this is going to give us 2 divided by 2 plus or minus 4 divided by 2i, and this is going to give us 1 plus or minus 2i. And this is of the form u plus or minus vn I. So my u is equal to 1 and my vn is equal to 2. Good. Now what can I do again? I can write the initial condition. So I said the initial condition, the general solution. So general solution is equal to e to the power ux k1 cos vn x plus k2 sine vn x, close the bracket. And then I know that u is 1, and then I know that vn is 2. So I'm going to have something like this. So basically here, the only problem here is also the differentiation, right? So you should be able to know how to do the differentiation very well, because we have initial condition which goes with y prime. So we need to find y prime. So what is y prime? I can simplify this and write it as k1 e to the power x cos 2x plus k2 e to the power x sine 2x. So I just multiply this to this. So what is y prime? When I want to differentiate this is a product rule. So I maintain k1, right? So when I maintain k1, I'll differentiate this and maintain this. So when I differentiate ex, I get ex, then I maintain cos 2x plus, now maintain ex and differentiate this. When I differentiate cos, I'll get minus sine. Then when I differentiate what is inside, I'll get 2. So this is going to give us minus 2e to the power x sine 2x. I hope you had the differentiation here. So maintain this, maintain cos 2x and differentiate ex. You get the same thing. Now we maintain ex and differentiate this. When I differentiate cos of 2x, I'll get minus sine. And when I differentiate 2x, I'll get a 2 here. So that is how I had that one there. Then same thing for the other one, plus k2, k out. I do the same thing here, product rule. I maintain sine 2x and differentiate e to the power x. I get the same thing, plus, now I maintain e to the power x and differentiate sine. When I differentiate sine, I'll get cos. And when I differentiate 2x, I'll get 2. So I'm going to have 2 e to the power x sine 2x. Close the bracket. So basically, this is what I'm getting. Okay, I have another space at the back. So this is my y prime. This is my y, which is the general solution. So let me just copy this one to the next page so that we can use the initial condition to solve them. Good. So we have the general solution. So this is the general solution. So initial condition, first initial condition, y of 0 is equal to 1. So y of 0, we need to use the one with y and x. So y and x is this one. So y is equal to 1, x is equal to 0. So 1 will be equal to, so 1, this is 1, is equal to e to the power 0, in bracket, k1 cos of 2 times 0 plus k2 sine of 2 times 0. So e to the power 0 is 1, then k1 cos of 0 plus k2 sine of 0. What is cos 0? Cos 0 is 1, yes. And then sine 0 is 0. So we are going to have 1 is equal to 1 times k plus 0. And this is going to give us k1 is equal to 1. So we have gotten k1 to be equal to 0. Let's find for k2 using the y prime. So y prime of 0 is equal to 1. Yes. So it means that x is 0, y prime is also 1. So we are using this huge derivative here. So y prime is 1, which is equal to k1, open bracket. So I'll put 0 here. So I'm going to have e to the power 0 cos of 0 minus 2 times e to the power 0 sine of 0. I think that's all from there, yes. Then plus k2 e to the power 0 sine of 0. Is that right? Yes. Plus 2 e to the power 0 cos of 0. Good. So now let's simplify. So just plug in, wherever you see x, you plug in 0, and y prime is equal to 1. So this is what we are going to get. Then 1 is equal to k1. This is e to the power 1 is 1, cos 0 is 1, minus sine 0 is 0, so everything will be 0 from there. k2, sine 0 is 0, everything goes 0. This will be 2 times 1 times 1. So this is going to be 1 is equal to k1 times 1 plus k2 times 2. So what are we going to get? 1 is equal to k1 plus 2k2. But we know that k1 is equal to 1. So this is 1 plus 2k2. And then move 1 minus 1 is equal to 2k2. 0 is equal to 2k2. And then this implies that k2 is equal to 0. So this is kind of very simple. So now that we have the general solution, we can write the particular solution. So the particular solution is going to give us y is equal to, we are going to have e to the power x, and then k1 is 1, so we are going to have cos of 2x. K2 is 0, so this is 1, so sine 2x. So this will simplify to e to the power x. Y is equal to e to the power x cos 2x. So this is what you are going to get at the end of the day, because this is going to be 0. And then when I multiply this one by this, we're going to get. So this is the particular solution, and this is the general solution. So as I said, when you differentiate this one first and second, and you plug it inside this, you are going to get the 0 here, as we tested in the previous video. Let's do last one, then I'll give you the room to also try. So now let's go through the same process again. Y is equal to e to the power mx. Y prime is equal to, so you see the way I'm practicing, basically it's helping me to understand everything that I'm doing. So because I'm solving, I'm practicing, I know the steps. So basically that's what you need to do. After here, practice them. The question that I solve, you can also solve them again, and then it will help you to engage with the material. So factor e to the power mx out. M squared plus 4 will be equal to 0. Then set this guy not to be 0. And then we are going to have m squared plus 4 is equal to 0. So this is m squared is equal to minus 4. Then I pick square root of m squared, square root of this. So m is going to be plus or minus 2i, right? Square root of 4 is 2. Square root of minus 1 is I. So that's what we are going to get. So here we can see that this is of the form u plus or minus, this of the form u plus or minus vn I, right? But here I can write this one as 0 plus or minus this. So this implies that u is equal to 0 and vn is equal to 2. Good. You know, here the idea is that vn can never be 0, because as soon as vn is 0, we go back to the previous method, either method 1 or method 2. But here u can be 0, and still we will be with the method 3. So our general solution is going to be e to the power ux k1 cos vn x plus k2 sine vn x. So we know that vn is 0, u is 0, so k1 cos 2x, k2 sine 2x. Now you can also write your formula by changing it to, let's say, alpha plus beta I, so that here will be alpha and this will be beta, this one will be beta. It's also the same thing. So our general solution is going to be k1 cos 2x plus k2 sine 2x. So very simple from there. Now let's just do initial condition and we are just done. Let's differentiate. When I differentiate cos, I get minus sine. I differentiate what is inside, I get 2. So I'm going to have minus 2k1 sine 2x plus, when I differentiate sine, I get cos, and when I differentiate this, I get 2. So I get 2k2 cos 2x. So this one will help me to use the initial condition. So let's use the first initial condition. Y of 0 is 2. I don't know why all my question x is 0. We have questions that x is not 0. So you need to pay attention to those ones too. You can have maybe initial condition that says that y of pi over 2 is something like this. And it's also going to work. So let's see, this is y is 2, x is 0. So we are using the general solution. This is the general solution. I love second order homogeneous equation because it's kind of very easy to, go through. When you just practice, you will see that it's kind of like very simple, very, very simple to work with. So 2 is equal to k1 times 1 plus k2 times 0. Sine 0 is 0. So 2 is equal to k1. Then we use the other one, y prime of 0 is 0. So y prime of 0 is equal to 0. So now we are using this guy. So I'm going to have 0, which is equal to minus 2k1 sine 0 plus 2k2 cos 0. So 0 is equal to sine 0 is 0. So this is minus 2k1. This one is going to be 0 plus 2k2 times 1. So I'm going to have 0 is equal to 0 plus 2k2, and this implies that k2 is also equal to 0. Good. So with that, we can write the particular solution. Let me just squeeze the particular solution here. So particular solution is going to be, now k2 is 0. We just have k1, which is 2. So it means that k2, this one will go to 0 and it will be left with this. So this will be y is equal to 2 cos 2x. So this will be the particular solution. So if you have gone through all the three methods, you will see that they are very simple, right? They are very, very simple. The idea is that let me say, it's like kind of following the same procedure. When we start from the first, you see that method 1, method 2, method 3, it's basically you are going to have something like this. You go through the same process like this, and then also the same like this. Either you use a quadratic or you use the factorization, you are going to get the same thing. The only changes is when you have the only changes is the root, right? So when the root is double, then I know the general solution formula that I need to use. And then when they are distinct, I know the general solution that I need to use. And when it is complex, and then I know the general solution that I need to use. So try this, it's your turn. Try this and leave your answer in the comment section. So this is the end of homogeneous second order differential equation. So in the next video, we are going to start the idea of non-homogeneous differential equation. And this is it. The idea that we've learned here with the homogeneous, please understand them before we start the non-homogeneous, because the idea is that whenever we have the non-homogeneous, we saw that it is let me say ax, or let me say a y prime prime plus b y prime plus c y prime to be equal to gen of x. Anytime we want to solve, this is what we do. We make sure that we pick the homogeneous aspect. Good. So I'm picking the homogeneous aspect. I'm going to solve it going through this three method before now I add the non-homogeneous aspects to it. Is that right? So in the next video, I will just show you how to do it. But try and understand all the three methods so that it can help you to appreciate what you are going to do in the next video. So see you in the next video.